All right, welcome. So today we are going to talk about 7.7. This is transforms of periodic, and never mind power functions. I've actually, well, maybe we'll see. We'll see. I think power functions may go later, but you never know. But let's just call it 7.7. We're going to really focus on periodic functions, the first set of videos I'm making here. I may go back and put some power functions in as we need them, okay? All right. I know that sounds weird. All right, let's get with the periodic function. So let me move this. Okay, so f of t is periodic with period t if f of t plus t equals f of t, okay, with some t, capital T, greater than 0. Okay, so a typical example is like your sine function. And actually, if you look back at the last video I made in 7.6, there's we dealt with a sine function, right, on a period, and we did it. So a lot of what we're going to do right at the beginning is going to mimic that, okay? So our first theorem, our first result, says that if f is periodic, with period t, okay, and continuous on 0 comma t, then, okay, the Laplace transform. Now here, this is the Laplace transform for the whole for 0 to infinity, the full Laplace transform. Okay, is related to f sub t of s, which we're going to write, this is the integral from 0 to t, okay, e to the negative st f of t, okay, by the full Laplace transform is equal to the periodic Laplace transform divided by 1 minus e to the negative st. Okay. There should be a t there. I don't know. There we go. Okay. Sometimes there's a lag. Yay. That's awesome. Okay. So let's go ahead and prove that. And if you don't, you have trouble seeing the proof, you want to see it for like a specific case, we did the exact same argument we're going to do. This was the last problem last time, okay? We're dealing with the function sine of t. Here we did it from 0 to 2 pi. And look what happened. We got this there we go. Very similar idea, okay? We'll go ahead and do it here, though, for this one. Okay, so let's let f sub t of t equal f of t times the window function from 0 to t. Okay, so remember what the window function is. That means it's 1 between 0 and t and 0 everywhere else. Okay? So that we can write as a combination of step functions. Remember, that's a combination. That's f of t times u of t minus f of t times u of t minus t. Okay, so what's that? Remember that u of t minus a equals 1 if t is bigger than a, and 0 if t is less than a. All right. So now, okay, let's take the Laplace transform. Now, the Laplace transform of this thing, of f sub t, is going to equal this thing. Okay? Let me write that down. So f sub t of s equals the integral from 0 to t. Write it a little bigger. Oh, annoying. Okay, from 0 to t, okay, f of t e to the negative st dt equals the integral from 0 to infinity f of t times these window functions, or times this window function, which I'm going to write it as u of t minus f of t u of t minus t. Should have an e to the st, e to the negative st, of course. Now, this u function, the first one, there we go, the first u function, the just u of t, that doesn't actually change the Laplace transform at all, does it? Because it's still the same thing, right? So this equals f of s minus the integral, let's write this 0 to infinity, f of t u of t minus t e to the negative st dt. Okay, but now what about the u of t minus t? Give me just a second. Okay, so now here, since f is periodic with period t, right? F is periodic with period t. Hold on, there we go. F is periodic with period t. Oh my gosh, this is really annoying. Okay. Then I'm going to rewrite this as f of s minus the integral from 0 to infinity f of t minus t, because it's the same as f of t, u of t minus t e to the negative st dt. Okay, now this, I can look on my table of integrals. Okay, I should have included in this thing, but I can, you guys have it. This is just, this is of course f of s. This is e to the negative st, capital T, f of s. Okay, I think that's number 10 in your integral chart. Okay, so now we've got it. Okay, because we've got f of s here, f of s here, ft of s here. We can just simply write then f of s equals f sub t of s over 1 minus e to the negative s capital T. Okay? All right, I'll see you all in the next video.